in this question, we find the ratios of trapeziums DCMN and MNBA. We know area of trapezium is given by half of sum of parallel sides. So for DCMN, we get half of CD plus MN. For MNBA, we get half of MN plus AB. We know CD and AB, but MN is unknown to us. So remember these two equations 1 and 2. Now let's jump to the property of non-parallel sides of trapezium. It says line that joins the midpoints of the non-parallel sides is parallel to the bases and is equal to half the sum of the bases. With this, we can easily get the value of Mn as half of AB plus CD, which comes out to be 40 centimeter. Now remember 1 and 2, substitute this value of Mn in equation 1 and equation 2. We get area of DCMN as 70 upon 2, and similarly we get area of MNBA as 90 upon 2. Now we jump to the ratio part. So ratio of these two trapeziums is solved as this: 70 upon 2, 90 upon 2, that comes out to be 7 upon 9, which is 7:9. Question 57, we find the ratio of weight of 1 cubic centimeter of wood to 1 cubic centimeter of sand. For this, we first find the volume of rectangular box, L into B into H, which is 1080 centimeter cube. Now for volume of internal box, we subtract 0.5 from 10 and from 6. That comes out to be 9 and 5. So volume of internal box becomes 765 centimeter cube. Now of course, volume of wood will be volume of rectangular box minus volume of internal box, which comes out to be 315 centimeter cube. So, if we find the weight of 315 centimeter cube of wood, which is 15 kg, we can easily find the weight of 1 centimeter cube of wood, which comes out to be 15 upon 315 kg. That means 1 upon 21 kg after simplifying. Now, weight of sand would be 100 kgs minus 15 kgs, which comes out to be 85 kgs. So that means weight of sand, 765 cubic centimeter of sand is given as 85 kg. So volume of 85 kg is equal to the volume of internal volume of the box, which is 765 centimeter cube. Again, the same method, weight of 765 centimeter cube of sand is 85 kgs. And weight of 1 centimeter cube of sand will be 85 upon 765, which comes out to be 1 upon 9 kgs. Now ratio of weight of 1 centimeter cube of wood and weight of 1 centimeter cube of sand would be given by their values that we found out, which is 1 upon 21 upon 1 upon 9, which comes out to be 9 upon 21 or 3:7, which is the required ratio, 3:7. Now in the next question, we are given this figure. We need to find the length of BS. So here kids, we know that ABCR is a square, so all sides are equal. And CQ equal to CB plus QB. So we get the value of CQ. We need to find BS. BS is the blend of AS plus AB. So let's find AS now. Consider the triangle CRQ and triangle ARS. As you can see here, angle A equal to angle C and sides are equal. So by RHS congruency rule, we can easily prove that CRQ triangle is congruent to triangle ARS. By this, we get the corresponding sides AS equal to QC. Therefore, AS becomes 55 centimeters. Now we put this value of AS in equation 2 to get the value of BS, which was AS plus 27. That means 55 plus 27. So we get BS as 82 centimeters. And now the next question requires the rationalizing of numerator and denominator. So as we change this divide sign into multiply, this right hand side term will be the reciprocal of it. Now let's first simplify this by assuming a few terms as A, B, C and D. Now as we simplify this in equation 1, we get our equation, our term in the form of A plus B into A minus B in numerator and in denominator as c plus d into c minus d. Now just by looking at it, we can easily use the identity in this full term in numerator and denominator, and we get here the equation as a square minus b square upon c square minus d square. And now therefore this is written as a square minus b square and c square minus d square. Multiplying the under roots together, everyone knows then under root is not applicable. So therefore we get the term as a square minus b square upon a square plus b square minus b square. Therefore we get it simplified it to b square upon a square. Now question number 60, which is also the last question of this paper. Now problem 1 is solved by 70%, problem 2 is solved by 60%, and every student solved at least one of the problem. And we are given that 9 students has solved both the problems, which is the common area I have shown here. Let us assume the total students be x. That means problem 1 is solved by 70% of x and problem 2 is solved by 60% of x. Now, if we add 0.7 plus 0.6 and we subtract the common kids, we get the total number of students as x. Here we solve this linear equation in one variable for x, we get x as 30. Therefore 30 students.